Hello there. This is a short summary of our recent work, Navigation with Large Language Models, Semantic Guesswork as a Heuristic for Planning. I'm Dhruv, and this is joint work with my collaborators Michael, Blazej, Faye, Brian, and Sergey. We study the question of how we can leverage the semantic knowledge stored in large language models for guiding real-world robot exploration. Let's say this robot is asked to find toilet paper in a house it has never visited before. It must use its visual observations to parse the environment and efficiently explore it. While many recent works have explored the use of large language models to drive robot actions, this can be a challenge because LLMs are not typically grounded in the physical world and tend to hallucinate about observations and patterns in the environment. Furthermore, sequential conversations with LLMs may lead to poor long-term memory for decision-making over extended periods of time. Rather than directly asking the language model for which action to take, our key insight is to extract goal-directed scores from the language model and use these scores as a heuristic for a high-level planning algorithm. The LLM can also provide a justification for its actions, making the learned heuristic interpretable. We instantiate LFG on top of a simple frontier-based exploration algorithm that can use either a topological or a geometric representation of an episodic memory of the environment, and generates sub-goal proposals at the frontier. We use the language model to score these proposals using our novel scoring algorithm, and then use these scores as a heuristic for exploration in novel environments using a search algorithm such as A* to search for the goal. The selected sub-goal is passed to a low-level controller, which may be deterministic or learned. LFG is a versatile way to score sub-goal proposals and is compatible with a wide variety of underlying exploration algorithms, either scripted or learned. It can also work with different memory representations. Our scoring algorithm has three key components. Rather than using the next token likelihoods, we sample or poll the language model to generate a large number of candidates and estimate likelihoods for subgoals empirically. We use a combination of positive and negative scores from the language model to get unbiased scores from the language model. And lastly, we prompt the language models to construct a narrative that justifies their reasoning, adding interpretability to our scores and increasing the robustness of these scores. Let's look at some examples of LFG in the real-world apartment building. When faced with a decision, LFG uses a vision language model to detect and describe objects at its frontiers, and queries the language model to score these sub-goal frontiers. In this case, the language model crafts a narrative about how the oven is likely to be close to a refrigerator since they're both typically found in the kitchen, and successfully guides the robot to the kitchen. Here's another example in the same apartment, now looking for a toilet. The VLM, which in our case is TTIC, detects many relevant objects, and the LLM reasons over them that while the toilet is not visible in either directions, it is more likely to be near the beds in a bathroom rather than near a refrigerator in the kitchen. The robot then drives into the bedroom and eventually reaches the toilet successfully. Here's another example where the robot does not have enough information to make the decision. For instance, when it's driving between the couches and the windows, the robot is guided to continue undirected frontier exploration by the LLM, relying on the underlying planner. When the robot's observations get more useful information, in this case, a refrigerator and some cabinets in the distance, the LLM suggests that exploring near the refrigerator is more likely to lead to the oven since they're both in the kitchen. The robot drives towards the refrigerator and eventually reaches the kitchen. Thank you for your interest in our work. Please see the project page for more videos, code, and an interactive Colab notebook demonstrating the algorithm.